Hello everybody and welcome to this channel. In this video we will discuss the meaning of redox reaction. We will look at how to know whether a reaction is a redox reaction or not. We will also look at how to determine a reduced and oxidized species in a reaction, and also how to determine the oxidizing and the reducing agent. You can't escape this kind of question in CHM 101. Also, how to assign oxidation number and calculation that are involved, and some practice problems to show how to approach CBT problems under the redox reaction. Now, in another video, I will dedicate another separate video on how to balance redox reaction in alkaline and acidic medium, and some calculations that are also involved in this. So do not forget to subscribe to this channel so as to be notified whenever I release the video. Subscribing to this channel is absolutely free. Just press the subscribe button and click the bell icon so as to get notified whenever I release the video. Now let's get into business. Now, a redox reaction simply means a reduction and oxidation reaction. So redox means a reduction and oxidation reaction. So what does that mean? Now we can define redox reaction in many ways. So one of the most commonest definition is in terms of oxygen. So and redox, oxidation in terms of oxygen is the addition of oxygen to a species, while reduction is the removal of oxygen. So it's the removal of oxygen. Now we can also define oxidation in terms of hydrogen. Now in terms of oxygen, it means that reactions like Mg plus O2 to give 2MgO is an oxidation reaction because it involves the addition of oxygen. Now in terms of hydrogen, oxidation is directly oxidation and reduction are directly opposite to that of the in terms of oxygen. So in terms of hydrogen, oxidation is the loss of hydrogen, negative loss of hydrogen. Now reduction is the addition of oxygen to a species. So that means that reactions like copper oxide plus H2, where we are adding hydrogen to get this, is actually a redox reaction, and it is specifically a reduction reaction because reduction is the addition of hydrogen. Alright, so one of the most commonest way, because sometimes you might not see oxygen and hydrogen in a reaction and the reaction will be a redox reaction. So how would you know? Well, we can also define it in terms of electron. So in terms of electron and in terms of oxidation number. So we have what we call oil rig. I use these mnemonics to remember in terms of electron. So that means that oxidation is loss of electron and reduction is the gain of electron. So reactions like Fe3 plus E minus to give Fe2 plus, this kind of reaction would be a reduction reaction. A reduction reaction because it involves the gaining of electron. Now reactions like Fe2 plus to give Fe3 plus electrons is actually an oxidation reaction because it involves the loss of electron. So it has lost one electron. So we also have reactions like zinc 2 plus 2E minus to give zinc. So this kind of reaction will be a reduction reaction because it involves the gain of electrons. And also O2 plus 4E minus to give 2O2 minus is also a reduction reaction because it involves the gaining of electron. Now in another way, we can say that oxidation is the increase in the oxidation number. So in a reaction whereby the oxidation number of a particular species increases, so we say that this is oxidation reaction. Now when the oxidation number of a species reduces, that means that the reaction is a reduction reaction. So an example is what we have seen over here. You can see that the oxidation number of ion A has reduced from 3 to 2, so that means that it's a reduction reaction. The oxidation state of ion A has increased, so that means that it's a reduction it's an oxidation reaction. Now here we have zinc 2 plus to give zinc, which is neutral. Of course, it's in 0 oxidation state here. That means that it has reduced, so it means that it's a reduction reaction. And of course here it's having 0 and here it's having 2 minus, so it has reduced from 0 to 2 minus. So that's also a reduction reaction. Now, how can we know if a reaction is a redox reaction? It's one of the questions you would likely not to miss in CBT. So how do you know if a reaction is a redox reaction or not? Now, before we do that, let's look at how to assign oxidation number to atoms and species in reactions. Now, we must know that the oxidation number, there are some rules for them. Now, basically, if you have any substance, any species, like maybe N2, Na plus, H2O, Na, NO3 minus. So basically, if it is just an ordinary atom or an anion that contains just an ordinary atom, the charge it bears is the same in magnitude and charge, as its oxidation number. So that means that for this anion over here, the oxidation number of sodium plus will become plus 1. Also for calcium 2 plus, its oxidation state will correspond to the charge it has, which is plus 2. For carbon, it is neutral, so that means that it will be having 0. Then it's the same thing for sodium. In its uncombined state, in its normal state, it will be 0. Now for, if you're having molecules or radicals, cations like this, so the sum of the oxidation number of all the elements in that compound will be equal to the charge of that compound. So the oxidation number of, H2 plus that of oxygen in this compound, when you sum them together, will give you 0, because overall the compound doesn't have any charge. Now the oxidation number of nitrogen and that of the 3 oxygen here, when you add them together, you should have negative here. So that's how to that's one of the rules. The algebraic sum of the oxidation number in a covalent compound is actually 0. Covalent compound like HCl, like that. Also, elements in their uncombined state, in their standard state, have an oxidation number of 0. Like I just mentioned, like Fe in its uncombined state, Cl2, O2, like that, they have 0 oxidation state. Now, oxidation state of oxygen, because oxygen is one of the is one of the elements that you always encounter in compounds. So now oxygen has oxidation state of -2. Please make sure you are noting that. That's like the rule theory. So it has oxygen number of -2, except in peroxide. That it has oxidation number of -1. Now, what are peroxide? Peroxide, they are compounds in which there is oxygen to oxygen single bond. For instance, we have sodium peroxide, we have hydrogen peroxide. So in this peroxide, we should have hydrogen bonded to one of the oxygens and another hydrogen bonded to one of the oxygens. So this is peroxide. We also have sodium peroxide. There will be oxygen to oxygen single bond in sodium, and we have sodium. So in this kind of compound, oxygen exists as -1 oxidation state. It exists in -1 oxidation state. So that means that normally, if you want to calculate the oxidation state of a particular element and you have oxygen there, normally the oxidation state will be -2, except if that compound is peroxide. That's when you assume that it's -1. Also, the oxidation state of hydrogen doesn't normally change. It is always +1, except in metallic hydride. Metallic hydride like sodium hydride, calcium hydride, like that. So hydrogen will be having -1 oxidation state in metallic hydride. Please do not forget that these are the rules that we'll be using to determine the oxidation state of species. Now, in all compounds, alkali metal, the group 1 metals, they have +1 oxidation state in all their compounds. And the same for group 2, they have +2 oxidation states. Also, +3 for group 3 metals as well. Now, sometimes you might be asked to determine the oxidation state of some elements. Also note that for halogens, all halogens, they are having -1 oxidation state. Now, with this, you might be asked to do some calculations here. For instance, you might be asked to determine the oxidation state of nitrogen in this compound. Now, basically, the hydrogen the compound, the element you will be asked to find its oxidation number will be element that has variable oxidation number. Normally, you will not be asked to find the oxidation number of nitrogen here because normally it should be -2, except in peroxide. So nitrogen can exist as +3 and +5. So that's why you'll be asked to find its oxidation state. So you know that from the rule, if you sum the oxidation state of this nitrogen, which you don't know, let's call it X, plus that of this oxygen. Oxygen is -2. Now we're having 3 of them. Then if you sum them together, you should have the charge on the whole compound, which is -1. So this means that X minus 6 will give you -1, and X becomes 6 minus 1, which is equal to +5. You must indicate that because oxidation state can also be negative. Now also, you might be asked to find the oxidation state of, for instance, vanadium in VO2 plus. So all you just have to do is to assume that to say the sum of the oxidation state of vanadium plus that of the 2 oxygens will give you +1, which is the magnitude of the charge in the ion. So that will be X minus 4 equal 1. So X equal 4 plus 1, and that's +5. Okay, so that's how to do that. So these are the possible questions you might be given. Also, you might be asked to find the oxidation state of phosphorus in P2O7 4-. So now we have 2 of phosphorus. Now that means that 2 times the oxidation state of phosphorus plus the oxidation state of oxygen is -2 times 7, because we have 7 of those. That will be -4 equal to -4. When you add the oxidation state of all the elements, it will be equal to the charge of that ion. So that will be 2x minus 14 equal -4. So that means 2x equal 14 minus 4. That was 2x equal 10. So x equal 10 divided by 2, and that is 5. So you may see questions like this very well in the exam, so you should watch out. And also we have CHCl3. You're asked to find the oxidation state of carbon. Now, you know, if you add the oxidation state of carbon plus that of the hydrogen, you know, we say it should be always +1, except in metallic hydride, plus chlorine, it's an halogen, and we say for halogens, all of them are having -1, so that will be -1. We have 3 of those. Then this will be equal to, when you sum all of them, it should be equal to 0, because the whole compound doesn't have any charge. So this becomes x plus 1 minus 3 equals 0. That means x minus 2 equals 0, so x equal 2, like that. So that's how you do it. And these are the examples that I have over here. So you can try for this first example and tell me the answer in the comment section. Na2S4O6. So find the oxidation state of sodium in this compound, and make sure you tell me in the comment section. If you are correct, I will mark it to be correct, and if you are wrong, I will tell you the solution. Alright, so these are the problems that I have over here with me. Now, this is how to determine the oxidation state of elements. Now, next is to know how to determine whether a reaction is a redox reaction. Now, basically, if you want to know whether a reaction is redox or not, all you just have to do is to check whether there is change in oxidation state of any element in that reaction. For instance, let's consider let's consider the reaction HCl plus sodium hydroxide to give sodium chloride plus H2O. You will notice that here the oxidation state of hydrogen is, before the reaction, and after is +1 here, and it's also +1 in water, right? It doesn't change. For chlorine, it is -1, and here also it is -1. For sodium, it is +1 here, and it's also +1 here. For oxygen, it is -2. And also here it is -2. So there is no change in oxidation number in this reaction. So that means that this reaction is not a redox reaction. Now we have the question here. Which of the following reaction is a redox reaction? Which of the following reaction is a redox reaction? Now we are given this from this question. We have this. The first option is option A, which is this. Then option B, we have calcium carbonate to give, this is the composition reaction, CO2. Then also we have N2 plus 3H2 to give 2NH3. So the state symbol, I mean whether it's in gas or liquid, is not really important here, so just don't worry about that. CO to give NH2, CO, NH2. Alright, so what you want to check is that you want to check whether there is a change in oxidation state of any element here. If yes, then the reaction is redox, and if no, the reaction is not redox. Now, basically in CBT, one of the techniques is that once you are checking from option A and you see that there is a change in oxidation number of a particular element in a reaction, you don't need to check further. That reaction will be a redox, and that's going to be the answer. So for A, we have checked that, so we see that it's not a redox reaction. That was what we did earlier on. Then for B, now decomposition reactions like this, well, let's check. For calcium, it will still remain +2. Of course, oxygen is always -2. So if you want to find for calcium here, it should be x minus 2 equals 0, right? That means x equals +2. So calcium is also +2 here. Now for carbon, carbon is +4 here. If you do it, that will be 2 plus x, right? 2, this is +2 plus x plus -2 times 3, all together will be equal to 0 because that's no charge. 2 plus x minus 6 equals 0. Then x equals 6 minus 2, that's +4. Also here, if you want to calculate for carbon, it should be x minus 4 because this is -2 times 2, all equal to 0, so x equal 4. So there is no change in oxygen number here too, so this is not a redox reaction. Now in this reaction, nitrogen is in all combined state, so that means that it is in oxygen state of 0. So hydrogen as well is also in oxygen state of 0. Now if an element is in a compound, it can never have, well, sometimes it might have, but it's very rare. For instance, in this kind of reaction, nitrogen will not have 0 as its oxidation state. Once it is combined, it will have a definite oxidation state. So it's enough to know that this is a redox reaction, because in the reactant side, they have the oxidation state of both nitrogen and hydrogen here, they are 0. Now, when they combine, they will definitely have a particular oxidation state, even before you calculate it. So that means that there is a change in oxidation state, right? Which is non-zero in this compound. So hydrogen will have +1 oxidation state. That means that it changes from 0 to +1. So then nitrogen as well will have -3 in this state. If you calculate, it will be x. Okay, you will not consider the coefficient when trying to calculate the oxidation state. So that would just be nitrogen that we want to determine, plus hydrogen is having 1, then times 3, all together when you sum it equals 0. So that means x plus 3 equals 0. That means x equals -3. So nitrogen changes from 0 to -3. So this is a redox reaction. So you don't need to even check this. For this is just like an isomerization reaction. Okay, it's just like an isomerization reaction, whereby this is just like urea changing to urea. It's another way of writing ammonium cyanate. So this is not, if it confirms, you see that this is not a redox reaction. So that's one. So anytime you are seeing a single atom, okay, at the reactant side, and at the product, the atom is now combined, then definitely that's going to be a redox reaction for this level. Now let's move on. I have another question here with me. Which of the following is a redox reaction? So A, we have KCl plus H2SO4, then to give KHSO4 plus HCl. Then the second one is 2FeBr2 plus Br4 to give FeBr3, 2 of those. Then we have 3AgNO plus FeCl3 to give 3AgCl plus FeNO3, 3. Then we have H2CO3 to give H2O plus CO2. Now from all the options, basically if you check here, you see that this is bromine. It's not combined with anything. So that means that here it will be having 0. Then here it is combined with something. It will be having an oxidation state of -1 here. Okay, so that means that this reaction is a redox reaction. You don't need to check further. This is a redox reaction. If you want to confirm this is having +1, the potassium is in group 1, so this one will be also having +1, so no change. For chlorine, it will be having -1. Here it will be having -1. Hydrogen +1. Hydrogen +1. So this is SO4. This is also SO4. So there's no change. So this will be having +6. This is also +6. Theta also sulfate 6. So this will be having -1, minus 2 as well. So you can confirm for other ones as well. So you would see that they maintain their oxidation state. Even for iron here, it's iron 3, right? If you want to confirm that x minus 3 equals 0, so x will be 3. Chlorine will be having minus 1. Silver here is having plus 1. Also here it will be having plus 1 because it's like x minus 3 minus 2 equal 0. Oops. This is also a redox reaction because there is change in oxidation state of silver here, right? So this is minus 3, this is minus 2 equals 0. So that will be x equal plus 5. Or even if you use plus 5 for nitrogen here, it will be minus 3. So there is a change in oxidation state in this in this reaction as well. So that means that this reaction is also a redox reaction. So we have that. Although in the options we just only have one of them. So this is one of the stuffs that I wrote out. So you can try for this question and tell me the answer in the comment section as well. HNO3 to give MgNO3 plus NO2 plus H2O. Then we have KCl plus AgNO3 to give AgCl plus KNO3, FeSO4 plus KClO3 to give KCl plus Fe2SO4 3. Then we have barium chloride plus sodium sulfate to give barium sulfate plus 2NaCl. Now one thing is that anytime you see a displacement reaction, this is just like a displacement reaction. This anion here displays the anion here, there would be change in oxidation state. So this one basically is not a redox reaction, and in fact you can even guess this is a redox reaction from here because it's having 0 and here it will have a particular value, maybe plus 2. So this is a redox reaction. I've even answered it myself. All right, so you can just confirm whether other ones are not redox, but they shouldn't be redox, this shouldn't be redox, this shouldn't be redox as well. So because you can only have one option. So now let's look at how to determine which species is reduced and which species is oxidized, because of course you might be asked as well that which species is oxidized and which species is reduced. For the following reactions, state which species is reduced and which is oxidized. Now let's say we have let's start from the simplest one. Let's say we have zinc 2 plus Cu plus to give Cu2 plus zinc plus. Now you can see that this from here, right, this is reduction, okay, and also from this to this is oxidation because there is increase in the oxidation number. Now what can you say about this? Which one is reduced, which one is oxidized? Of course this has passed through oxidation, so that means that this is oxidized. This species is oxidized and this is reduced. Now one of the tricks of answering question here is that anytime you are asked which is reduced and which is oxidized, your option can never be from the product. It will always be from the reactant. So of course you have the option of eliminating two options. For instance, which of this is reduced and which is oxidized. So you might put A this, B this, C this, and D this. So of course you can eliminate the product and confirm from your reactant which is oxidized and which is reduced. So this one that undergo reduction is reduced and this is oxidized. All right, let's see this Cl2 plus 2Na to give 2NaCl, which is reduced, which is oxidized. So all of them, the two of them are in either in 0 oxidation state here. But here you see that sodium is in +1 and Cl is in -1. So for Cl it goes from 0 to -1, and for sodium it goes from 0 to +1. So that means that sodium has increased in oxidation state, and the increase in oxidation state is oxidation. So that means that sodium has been oxidized and chlorine has been reduced. All right, so let's see this question as well. Fe2 plus to give Fe3 plus E minus. So of course you can see there is reduced. In fact, this kind of reaction you don't even need to determine anything here. This is just plainly oxidation. So this is oxidized because it has increased in oxidation number. Now look at this. For the following reaction, which is reduced and which is oxidized, PbO plus H2 to give Pb plus H2O. There are many ways of answering this kind of question. First, you can say that, now look at this, Pb here, if you want to know the oxidation state, it will be X minus 2, right? For oxygen equals 0. So X will be equal to plus 2. So Pb was in plus 2 here. Now here it is now 0 because it is all combined states. So Pb has been reduced, right? And hydrogen here is in 0 and this one is in plus 1, even though oxygen doesn't change. Now, what would you say? In your option, you would see A, Pb, B, PbO, C, H2, and maybe D you might see maybe like Pb. So I want you to pause the video now and guess which will be the answer for this question. Pause the video and type it in the comment section. I want to know your opinion about this question. Alright, now basically Pb, the lead, has actually been reduced from plus 2 to 0, but Pb alone is not part of your reactant, and as I said, your reduced species and the oxidized species will be one of your reactants. So you don't say Pb has been reduced, even though it is the one that actually reduced, but you rather say that what PbO has been reduced. So even though one of the atoms of that compound is the one that's reduced, but you won't say that that atom has been reduced in your option. You rather say the whole compound has been reduced. Of course, PbO has been reduced to Pb. Now, basically, reduction is the removal of oxygen. So that means that the whole stuff that is here has been reduced to what? To Pb, because oxygen has been removed from it. So that means that this is the what? Is the reduced species, right? And this is the oxidized species, of course, from 0 to plus 1. And even if you look at it, it has gained oxygen to give H2O. So that means that it has undergone oxidation, because oxidation is the addition of oxygen. So those are the ways of knowing which is reduced and which are oxidized. Now, we have questions like, there's one particular question as well. So you can use that as practice. So tell me in the comment section below which is reduced and which is oxidized in the reaction I'm writing right now. So you can do that yourself and tell me in the comment section. So we have SO4 2 minus plus 4H plus 2CuCl. So tell me which is reduced and which is oxidized in this reaction. Now the next topic or the subtopic we need to talk about is how to identify the reducing agent and the oxidizing agent. Now let's look at the first reaction we talked about, the reaction of zinc and copper. Zinc 2 plus Cu plus to give zinc plus Cu2 plus. Now you must notice that in all the reactions we've been talking about, we call it redox. So that means that it is reduction oxidation. It's not possible for only reduction to occur, and it's not possible for only oxidation to occur. The two of them will occur at the same time. Because look at this, if you say oxidation is the addition of oxygen, that means that the species that has been oxidized has gained that oxygen from somewhere. So the one that gives out oxygen definitely has been reduced. So the two reactions occur at the same time. Even though this first reaction is reduction, because this has lost one electron. Zinc 2 plus simply means that it has lost 2 electrons. Now to become zinc plus, it means that it has lost just 1 electron. That means that it has gained 1 electron here. It has gained 1 electron because it has lost 2 here. For it to become a species that has lost 1 electron, that means that it has gained 1 more electron. So gaining of electron is reduction, and of course reduction in oxidation number also is reduction. So they don't contradict themselves. Now from here, it means this has it has gained 1 electron, right? Now this electron is coming from somewhere. So that means that it is from the copper plus that we're having here. it is the one that lost that one electron given to this zinc. So it lost one more electron, it becomes copper 2 plus. I hope you can see now. Now, which means that if there is no copper, now this is being what? It is being reduced. So because it gains one electron. Now, if there is no copper 2 plus, it will not gain the electron. So the copper 2 plus that gives it electron, it is the one that make it reduce. So this copper plus is the what? Is the reducing agent, because it is the agent that caused the zinc 2 plus to reduce. It gives it electron. At the same time, this has lost electron, right? Minus 1 electron. So it's what? It is oxidized. So if there is no zinc 2 plus, to gain the electron that it lost, then it will not lose that electron. So this zinc 2 plus that makes it oxidized is the oxidizing agent. Or simply put, if something is reduced, that means that it is the oxidizing agent. So one of the questions you will see is that, is oxidizing agent in the reaction get A oxidized, get B reduced, like that. So the reduced species is the one that's the oxidizing agent, while the reducing agent is oxidized in redox reaction. So the oxidizing agent, the reducing agent is oxidized. So as you can see. So also you can try another reactions like let's say we have reactions like even from here we can know which one is oxidized and which one is reduced. So because this is reduced from 0 to -1, so that means that it has undergone reduction, and of course because it is reduced, it will be the oxidizing agent. Now this one has increased from 0 to +1, so that means that it will be the reducing agent because it is oxidized. Okay, so that's how to know whether a reaction whether a species is oxidized or not. Let's say we have 3Ag plus Al to give 3Ag plus Al3 plus. So this actually has gone from +1 to 0, and this has gone from 0 to +3. So this is what? Reduction. It has what? It has gained one more electron to become neutral, and this has lost 3 electrons. Now notice that the number of electrons gained in oxidation is the same number of electron lost. Sorry, the number of electron gained in reduction is the number of electron lost in oxidation. So each of Ag plus loses 1 electron, gained 1 electron, and we have 3 of them. So the total number of electron gained in this reduction is +3. And the total number of electron lost here is also -3. So that means that it is balanced. So you can try these questions as well, add it to the 2 questions I've called. So to tell me in the comment section which of these is the reducing agent and the oxidizing agent. Sorry, I've not even answered this question. So for this, you can see that this has what? This has reduced. This has been reduced, right? For it to have been reduced, it means that it is the oxidizing agent. Why this that has lost electron, which is oxidized, so that means that it is the reducing agent now. So you can tell in the comment section which of the following is an oxidizing agent and which is a reducing agent for the following: plus NO K2MnO4 plus H2O to give MnO2 plus KMnO4 plus KOH. The last one, let's have iron oxide plus 3CO to give 2Fe plus 3CO2. Also, you might want to calculate the oxidation state of the atoms I would be choosing here. For instance, I think I've made this question already. So those are the questions I would be asking here. So no more question. Okay, from here, CH3OH, you can calculate the oxidation state of carbon and tell me in the comment section. So for those of you that might be interested in our tutorial, so we have tutorial for ordinary level, and even if you are not an ordinary level student that you are watching this video, We have tutorial for 200 level as well and 300 level, specifically chemistry, CHM 301, CHM 331, etc. For 200 level, we have all other courses as well. So, and for other level, we have many other level courses like CHM 101, CHM 115, physics as well. All your physics 125, 115, 191, we have all of those. And even the mathematics courses, we have 113, we have 115 and 111 as well. And for other courses like CSC, CS 111, we have them as well. And even I think PLB 101. So for all of these courses, if you need competent tutor to take you, you can just message us on WhatsApp. I will drop the number to message in the description. You can check that out. And also, I will be making some practice questions under this course. So if you are interested in those practice questions, you can just message the number as well. It is free of charge. You can just message me on WhatsApp and you have access to that question. So just tell me your name, your department and level, and tell me that you are interested in the tutorial if you want to register, or you are interested in the practice problem. Once you tell me, I will send it to you. Thanks for watching, and I'm going to see you in the next video. Don't forget, I'm going to make another video on how to balance chemical redox reaction in alkaline and in acidic medium. So make sure you subscribe now so that you can have access to that when it is released. Thanks for watching.